Section 1.4 to classify and name angles. An angle is a geometric figure formed by two rays with the same initial point. And this in the parentheses is a symbol for angle. So if I draw one ray with an initial point and then a ray that shares the same initial point, those form an angle. The sides, and there will be problems in the homework that specifically ask you for the sides. The sides of the angle are the two rays. So the sides for this angle would be ray OA. Again, you start with the initial point, which will be the center of the angle, and then pick a point closer to the arrow. Those need to be capital printed letters because they represent points. The bottom ray would be ray OB. O is the initial point in the center of the angle. B is closest to the arrow. Remember, those symbols above always point to the right. The vertex is that common initial point. So the letter that repeats, the O, is the vertex. And you will have a problem that asks you for the vertex, capital point O, and then the two sides of the angle. There are three different ways to name an angle. You can name it using all three letters around the angle in order, either angle AOB, capital printed letters because they are points, or angle BOA. The vertex, this O, needs to be in the center, and you need the angle symbol out front. So this is angle AOB or angle BOA. You can also use a number. The number must be inside the angle when you start the problem. You cannot add that in. Because this angle no longer has the third letter, I cannot name it with 3 points. I could just call it angle 1 because the number 1 was already inside. Again, you must use the angle symbol out front. A third way is if this is the only angle using this vertex in the center, then you can name it by the vertex. So this one could be called angle O. An example of when we couldn't do that is for a picture like this one. I could not just call this angle O because I'm not sure which angle you're talking about. In this picture, we have this first angle, which could be AOB or BOA. We must put the angle symbol out front, so angle AOB. We have this angle in the middle, angle BOC. This bottom angle, angle COD. There are other angles. There's the angle that's these two top ones together, so angle AOC. The bottom two together, angle BOD. And again, I could have called this one DOB or COA, as long as the O, that initial point, is in the center. And then the entire angle could be angle AOD or DOA. So there are lots of angles. Again, I cannot use numbers because they weren't in the picture to start, and we can't use the vertex O because we've listed 6 different angles that share that initial point and share that vertex. A protractor is our instrument that we use to measure an angle, and the protractor is the one that's a semicircle and has numbers. Degree is the unit of measurement we use for our angles. So if I measure an angle and it's 30, it's 30 degrees. Also, when we discuss angles, now remember these are rays, so they really do keep on going. Everything between the rays is the interior of the angle. Everything outside of those rays is the exterior of the angle. And there will be some problems where you plot points and draw an angle, and you need to pick a point on a graph that's in the interior of the angle and in the exterior of the angle. Congruent angles are two angles that have the same measurement. We're going to discuss this notation more. It's really important that we pay attention to when we use the congruent symbol, which is this first one, the equal sign that has the squiggle or a tilde on top, and when we use a regular equal sign. If you're talking about the figures and you say in the first box, angle A is congruent to angle B. Anytime you're talking about an angle and an angle, you use the congruent symbol. When we put the M out front, this stands for the measure of angle A. we're talking about the actual degree measure. Maybe it's 30 degrees, and the measure of angle B, maybe that's 30 degrees. That's when we use the equal. So if you put the M out front talking about the measure, how many degrees it is, we use the equal sign. Just talking about the figures, we use the congruent symbol. We've already talked about two of our postulates, or things that we accept without proof. The third one is called the protractor postulate, and it states that the measure of an angle is always positive. Even if the angle is drawn the way we normally see it, or if it's drawn backwards, it's still going to be a positive degree measure. We discussed that we can't have negative distances, we can't have negative angle measures. It's 30 degrees, 45 degrees, 1 degree, 170 degrees. It's never negative. Postulate 4, kind of like segment addition, this one is called the angle addition postulate. And again, we're going to use the name of this. Very important. We need to know angle addition postulate. This says if B is in the interior of angle AOC, then the measure, the M stands for measure, the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. And we're going to go to the next slide and we're going to draw a picture. So we're going to draw the measure of angle AOB. So angle AOB, angle AOB. Now again, the center one, the center letter, is your vertex. So I know O is in the center. I'm going to put AOB. When you name an angle, you go around it. AOB. Then we're going to add to that angle BOC. It's the same letter B, the same letter O. And so C would be out here. Angle BOC. And you can tell looking at the picture, if you add the first angle and the second angle, it does equal the measure of this entire angle, AOC. So some examples of this. Example 1 says the measure of angle AOB, M stands for measure, the actual degrees that it is 40 degrees. So AOB is 40. The measure of angle BOC, BOC is 35. And they're asking for the measure of AOC. That's the entire angle, AOC. So we're going to add those up. If the first one is 40 and the second one is 35, the angle addition postulate states if we add those up, then the measure of angle AOC, equals 75. Since you are giving a degree measure for the answer, you do need the M in front of the angle. This is the angle measure. Example 2 says the measure of angle AOC equals 130. AOC is our entire angle, so what you will see, especially in the book, is they'll do an arc for the whole large angle. This means the entire angle is 130 degrees. The measure of angle AOB, AOB, is this kind of small angle on the left, is 30. Then they're asking for the measure of angle BOC, kind of the larger angle on the right. This time we would subtract. If the entire angle is 130, this angle is 30 degrees. 130 minus 30 tells us that the measure of angle BOC would be 100 degrees. You can leave the degree symbol off or you can put it on, especially when we're taking a test. For some people, if you have handwriting that's not as neat, the degree symbol starts to look like a 0. So you want to be really uniform about that you either always use your degree symbol or you leave it off all the time. And I will take it without the degree symbol. We're going to classify angles, and we're going to classify angles by their measurement. And some of these words you're very familiar with. What this says is an acute angle is an angle with the degree measure x that's greater than 0 but less than 90. So if your angle is between 0 and 90, and it can be equal to 0, it wouldn't exist, it's not equal to 90, it's just less than 90, that's acute. And we usually talk about these being cute little angles. These are angles that are less than 90 degrees. If your angle measure x is equal to 90, it's a right angle. If it's between 90 and 180, it's obtuse, and we usually relate obtuse to the word obese. It's a large angle. If your angle measure is equal to 180, 180 degrees is a straight line, so this would be called a straight angle. You need to know these measurements for your test. What's acute, right, obtuse, and straight. Adjacent angles are two coplanar angles. Now, we've talked about planes as being a face of the box. We've talked about some problems where your plane is just your book page or your notebook page. So, our plane is going to be your computer screen. These are two coplanar angles. They're both on your screen, flat. They have the same vertex and one common side, but no interior points in common, which means that they're not overlapping. So these do not overlap. Sorry. They're next to each other. So we're going to draw a picture of adjacent angles. These are going to be two angles that have the same vertex. So here's my vertex, here's my first angle. They have a common side. So when I go to draw my second angle, it's going to use the same side, but they don't overlap. All of the interior of the first angle and all of the interior of the second angle are completely separate. They're next to each other. Those are adjacent angles. So this question has a picture. We have angle 1 is the small angle on the left. Angle 2 is this middle angle. Angle 3 is kind of down towards the bottom on the right. And it wants us to name two adjacent angles. Now, you could call the first one angle 1. You could also call it angle AOB or angle BOA. The small angle in the middle could be angle 2, angle BOC, or angle COB. The small angle kind of on the right towards the bottom could be angle 3, angle COD, or angle DOC. Again, you can often name angles with the vertex, but since O as a vertex has multiple angles that uses it, I'm not going to call any of these angle O. It's unclear which angle we would be referring to. So we could say that angle AOB and angle AOB, so BOC, are adjacent. They have those repeating letters, that common side, and they do not overlap. We could say that angle AOC, this large angle, and angle COD are adjacent angles. They share a side, but there's no overlap. This slide says name two non-adjacent angles. When we put the non prefix in front of it, it negates it. So we want two angles that are not adjacent. They're not next to each other. And there's two different things you could do with this. You could pick angle 1 or angle AOB. And to go with that, angle 3 or angle COD, because there's a space between those. Those are not adjacent. They're not next to each other. We could also pick two that do overlap, then they would not be adjacent. So I could use angle AOC, the large angle that contains angles 1 and 2, AOC, and angle BOD. These have overlap. They both include angle 2. They're not adjacent because they overlap. So if you want adjacent, they need to be next to each other and share a side. Non-adjacent, they either have a space between or they have an overlap. Our homework that we'll work on in class is page 29 to 32. We're going to do number 1 through 22, 26 to 28, 35 to 39, and for this first part, that is all the numbers. For the last part, 61 through 79, we're just going to do the odds. Those are review problems, and again, as you're working through the review problems, there is a section number to refer back to. Bring your questions with you to class, and we'll work on the homework.